In 5.8, we are going to use what we learned in 5.7 about Pythagorean theorem and talk specifically about one special type of right triangle, and that right triangle is the 45, 45, 90 triangle. So if we look at the 45, 45, 90 triangle, sorry, why isn't this working? Okay, so today we're talking only about 45, 45, 90 triangles and finding segment lengths. So if we remind ourselves what a 45, 45 triangle looks like, one angle is 90 degrees, and if this angle is 45 degrees, this angle has to be 45 degrees because all the three angles add up to be 180 degrees in a triangle. Now if we look at this, these angles are the same, so that means that these side lengths have to be the same, making it an isosceles right triangle. So an isosceles right triangle is the same thing as a 45, 45, 90 triangle. So today we're only talking about isosceles right triangles. Now the reason why these are so special is because these side lengths are going to be called this, these side lengths are going to be the same, so we can call them x. And what happens when we do Pythagorean theorem to find the hypotenuse is we're always going to get x radical 2, and I'll show you why. If we did Pythagorean theorem and we know this side's x and this side's x, we know that that's x squared plus x squared is going to equal c squared, and c is going to be this hypotenuse. So what is 1 plus 1 going to be? That's 2x squared equals c squared. And then what you have to do is square root it. Well, if you square root to get c by itself, the square root of x squared is going to be just x. So this one comes out of the radical. And the square root of 2, it gives you a decimal, so we're going to keep it in the radical. So the hypotenuse is always going to be x radical 2. So there's a long way to do this, and there's a shortcut to it. And you can do whatever you want. If this makes sense by the end of the notes, use this. If it doesn't, always, always, always use Pythagorean theorem. So, for example, number 1. I'll do it both ways. If this side is 45-degree angle and this is a 45-degree angle, then this side's 8, this side has to be 8. So if you did Pythagorean theorem, 8 squared plus 8 squared equals x squared. 8 squared is 64. 8 squared is 64. Add those two up and we get 128 equals x squared. And now we have to square root it. And remember, we have to simplify our radicals like we did in yesterday's notes. So radical 128, if you break that down by prime numbers, so 2, 3, 5, 7, 11, 13. Well, I know for sure 128 can be divided by 2 because it's an even number. So 128 divided by 2, you get 64. Now, 64 can be broken down into 8 and 8. Right here, you can stop because even though they're not prime numbers, because what just happened? What? This is a pair, so they go out together, and this is a loner, so it stays in. And we've accounted for everything. So really, x is going to be 8 radical 2, and that's your final answer. Nothing else will work. 8 radical 2 is the only answer possible. And I want you to look at the shortcut. If I know what this side length is, x, or in this case, 8, then that means that the hypotenuse is just going to be, well, I already know x is 8, it's just going to be 8 radical 2. So your hypotenuse should usually have a radical 2 sign in it. If this is a whole number, this will have a radical 2 sign in it. Okay, so let's try number 2. You can either do Pythagorean theorem, all this work right here, or you can say, if I know what the side length is, then I'm going to know what the hypotenuse is. So over here, the legs of an isosceles right triangle measure 7. So the legs are 7. So this is 7 and this is 7. We want to figure out what x is. Again, if you really want to do Pythagorean theorem because you love it that much, sure, go for it. 7 squared plus 7 squared equals x squared. 49 plus 49 equals x squared. And 49 plus 49 is 98. And then you get to do the radical, the prime factor tree. So 98, you can divide it by 2 and you get 49. I know 49 is the same as 7 times 7. These are a pair. They go out together. This is the loner. It stays in. So your answer is 7 radical 2. Now, the shortcut. If you know this side's 7, all you have to do is tack on or multiply a radical 2 to it, and there's your answer. All right, so number 3 is the same kind of concept. You can do the Pythagorean theorem if you want to. I'm going to try the shortcut. I know that the side length is 10 radical 2. All I have to do is tack on a radical 2, just like it did over here. But what is radical 2 times radical 2? Well, that's just going to be 2. And then what's 10 times 2? That's going to be 20. So your answer is going to be 20. If you really, really, really do not like to do it this way, that's fine. 10 radical 2 squared plus 10 radical 2 squared equals x squared. Now, if you square this, 10 squared is going to be 100, and 2 squared is going to be 2. And this is going to be the same thing. So we have 200 plus 200 is going to be 400. And when you square root 400, you're going to get 20. So that's the first type of question that you're going to see tonight on your homework. When they give you the side length, all you have to do is multiply by radical 2. Okay? If you look at 4, 5, and 6, they don't give you the side length, they give you the hypotenuse. If they give you the hypotenuse, that means you're going to have to divide by radical 2. So these ones, for this ones, you're multiplying by radical 2, and these ones you're going to be dividing by radical 2. Again, you can still do Pythagorean theorem if you want to. So Pythagorean theorem, x squared plus x squared equals 5 squared. 1x squared plus 1x squared is 2x squared. 5 squared is 25, and then you divide by 2, and you get x squared equals 25 over 2. Just leave it as a fraction, and then when you square root it, we have, well, that square root of 25 over the square root of 2. Well, the square root of 25 is 5, and then we have it over radical 2. Remember, yesterday we reviewed this stuff. We don't like to have radicals on the bottom. So that means we're going to multiply both the top and the bottom by radical 2. And this is going to be 5 radical 2 over 2 times 2. Radical 2 times radical 2 is just going to be regular 2. So this funky looking thing is going to be your answer. Okay? The shortcut is just to take the hypotenuse, 5, and divide it by radical 2. Once you have this step, once you see that shortcut, you are bypassing all this stuff and getting right to here. So all you do is multiply by radical 2, multiply by radical 2, and you get 5 radical 2 over 2. So you could do the shortcut, or you could do Pythagorean theorem. It really depends on how much work you want to do and whether or not you understand the shortcut. Okay? Try to do number 5. Pause the video and try to do number 5. Okay, number 6. The legs of an isosceles right triangle measure x. The hypotenuse measures 3. So if I drew a picture, boom, boom, boom. We don't know what the legs are. We'll call those x. We know the hypotenuse is 3. The shortcut is just to take the hypotenuse and divide it by radical 2. And then what you have to do, since we don't like the radical on the bottom, multiply, and you're going to get 3 radical 2 over 2. Done. If you really don't understand the shortcut, go ahead and do Pythagorean theorem. Trust me, you'll get the same exact thing. Okay, so reflection number 1, what's the relationship between the side lengths of 45, 45, 90 triangle? Go ahead and try to answer that reflection question. And then we have some fun word problems. Oh, I'm going to erase some of this. What is this? Go away. Thank you. Okay. So Jana is cutting a square of material for a tablecloth. That word square is super important. Whenever you see square, you're going to think of a 45, 45, 90 triangle because you have a square and you have 90-degree angles and all the side lengths are the same. And if you cut a diagonal, you're going to have a 45, 45, 90 triangle. Okay, so the table's diagonal is 36 inches. She wants the diagonal of the cloth to be an extra 10 inches long. What size square should she cut to make the tablecloth? So she doesn't really want 36. She actually wants 46 inches, right? And so she wants to know how long should the sides of the square be if she wants the diagonal to be 46. So we're going to call these x's. And they gave us the hypotenuse. So when they give you the hypotenuse, you're dividing by radical 2. If you don't like to do it that way, you could still do Pythagorean theorem. You're eventually going to come up with this. And then we don't like to have radicals on the bottom. So 46 times radical 2 over 2, and then some people stop here, but let's look at the whole numbers, because we can combine the whole numbers. We can't combine the radicals. 46 divided by 2 is 23, so your answer is really 23 radical 2. It says round it to the nearest inch. It's totally fine if you keep your answer like that, but if you did it in terms of inches, that would be about 33 inches. So she'd need to cut her square tablecloth to be 33 inches each direction. Try to do the same thing for number 8, and I'm going to check number 8, and I'm going to check number 5 to see if you did it. Where'd my recorder go?